Hello everyone, this is Abinaya presenting this video as a part of RECode 3.0 conducted by Coding Club of PSG College of Technology. This event includes solving two coding problems assigned in the Examly portal, followed by uploading an explanation video. As a part of that, we are creating this video. The first problem given to us is given a string containing digits from 2 to 9, written all possible letter combinations that the number could represent. Here, for example, if 2 is given, the corresponding string is ABC. If 3 is given, the corresponding string is DEF. We need to form all the possible combinations of these strings. So the input format is going to be a string representing the digit, and the output format is going to be the letter combinations. So for better understanding, we can see an example. For example, 23 is given as a string, 2 corresponds to ABC and 3 corresponds to DEF. All the possible combinations should be formed: A with DEF, B with DEF, and C with DEF. Finally, these many number of strings should be written as a list of strings. When we ran this code, all these test cases got passed. Now let's look into the algorithm. So the algorithm should follow something like: when a string is given, the digits should be extracted. From those extracted digits, the corresponding mapping should be taken. For 2, ABC should be taken. For 3, DEF should be taken. For that, it is easier to maintain a map that maintains a key value pair like this. For this particular character of digit, this string should get mapped. So first A should be extracted. For this test example 2, 3, first A should be taken from the string ABC, followed by DEF, and all the possible combinations should be done. A should be combined with D. Then we can reuse this A by eliminating this D alone, so that it can be combined with E. Then this D can be eliminated, so that we are left only with A, which can be then combined with F. All these strings generated can be added to the result simultaneously, and then it follows the same for B and C as well. Once the characters in the string got processed, we can end the step. So let's look into the code. The code follows like: the input string is stored in a variable input. The length of the input string is stored in n. When we use backtrack, this function is called by sending a result. Result is going to be the list of integers, and there is a mymap, which is the map containing key value pairs that we saw earlier. Input is going to be this digits, and 0 is the index from which we need to start processing this input. New string builder is called as path here. If I show the code, it will be better. So this is the code where the input is got as the string is got as an input and stored in the variable input. N is the length, and this is to handle the edge case. If the length of the input is 0, then we need to return simply an empty string. This is for creating the map that we discussed earlier. Result is going to contain a list of strings, so that we have declared here. Followed by that, we are calling a helper function that is called backtrack. Once this line is seen, the control goes here. So this is what we have been seeing in this part. In the function definition, the variables differ in their names, so the alias names are written below. From there, we maintain a variable called letters, which is going to have the string of the particular digit being processed. So 2, 3 is the input string, 0 is the index from where we need to start processing the string. The string 2, 3 at the position 0, the number is 2, and the corresponding string for 2 is ABC. We are considering that to be a character array and start processing each character using a for loop. For loop takes the first character and stores it in ch variable, and this is now added to the path. Once it is added to the path, a recursive call is made to the function backtrack by changing the index value to index plus 1, and path is going to be the intermediate path that is generated in this particular call. Once a recursive call is made, again letters is going to get the string corresponding to the digit which is present at the position 1 in the string 2, 3. That is, 3 is the digit that we are going to process now, and 3 corresponds to DEF. Again, a for loop is called where it is getting added to the existing path. The existing path here is A. D is now getting appended to the path. And once this is generated, again a recursive call is made. But since in the next recursive call, the index going to be passed is going to be 1 plus 1, which is 2. Once the index becomes equal to the value of n, that mentions the base case that we do not have any other digit in the given string to be processed, so we will end there itself. So this recursive call made here simply returns to the calling point, and hence the next step is to remove the last character. That is how we have coded. So the last character is removed. Before that, it is added to the list of strings, which we call here as result. Once D is removed, this is the existing path now. Then in the for loop, during the second iteration, the next character E is extracted. It is getting added to the intermediate path, that is A. Once that is added, AE is the next possible string, and that is added to the list. Here, when the recursive call is made again, it follows to the base case, and hence it returns simply from the call. And so E is removed from this intermediate string, and it is passed on to the next iteration where it is getting added with EF, and AF is another possible string that is getting added to the list. Once all these are done, this function call returns back to the calling point itself. From here, this marks the processing of ch is equal to A being done. Next, it will be followed by the second iteration of the for loop, where we will be processing the second character B followed by C, and that marks the end of the execution. And hence all the 9 possible combinations will be returned. This is a typical backtracking solution because it explores all the paths by generating the substrings level by level. So this is the code we have explained already till this. Inside the backtracking function, this is the base case when the index value is going to be equal to the digits.length, which is the input string that we have got. Then we can simply add the existing path to the result list, and we can return to the calling point itself. And this is where we maintain the string letters which is nothing but the corresponding mapping of the particular digit being processed at present. And this for loop is where we append the current character to the existing path, and here the recursive call is made by changing the index value to index plus 1. And once the processing is done here, the character which is present at the last in the path string should be deleted so that the generated substring so far can be reused for the next iteration as well. This marks the end of our first problem. When it comes to complexity analysis, it is a typical backtracking solution. We started with the empty string, then we appended the first character. This acts as the base substring to which all the other characters can get added. So AD is formed, followed by that we backtrack to the original substring from where E is getting added. After that E is deleted, backtracked, F is getting added, backtrack. Here A is almost completely processed. The substrings which can be generated by having A as the first character is now done. So it is backtracked again to the empty solution from where it is added with B, that is the path is appended with the character B. From there all the possible solutions starting with B can be taken. Once that is done, it is again backtracked, then all the possible paths of C is explored. Because of this reason, the complexity is going to be here it started with 3 and here 3 power 2. 2 here marks the number of characters present in the input string. For example, here we had only 2, 3. So that is called n here. Because of that, 3 to the power 2 is generated. But in the case of 7, the corresponding characters are PQRS, whose length is 4. If it is 9, the corresponding characters are WXYZ, whose length is 4. So in the general case, we can write it as O of 4 to the power n is the time complexity. And this is what explained here. Because it is implementing recursion due to backtracking, the recursion depth is going to be n, and hence the space complexity is O of n. Second problem is we are given with an array as well as an integer. We want to find a subsequence of numbers of length k which should have the largest possible sum among all the other possible subsequences. So the input is going to be an integer specifying the length of the array, followed by the array element itself, followed by an integer k, which is going to say the limit of the subsequent length. And the output format is going to be the elements which forms that subsequence, not the sum, but the element itself. So if we consider this, n is going to be 4 and 2133 is our array. 2 is going to be the length of the substring that should be generated. When we process this particular 2, then 2 can be the only element. When 1 comes, we maintain a min heap, which is nothing but a priority queue, with the parent being the smallest element, like 1 and 2 is maintained. When 3 comes, since the length is already k, which is 2 in our case, since the length of the min heap is already 2, we need to decide whether to retain this 1 or to allow this 3 to come inside. Since our objective is to maximize the sum, we need to remove the minimum element, which is easier in the case of min heap because the root element is going to be the minimum element. We just remove it and add this 3 into our heap and then reheapifying to maintain the heap property. When this 3 comes, we need to again decide here this 2 will be deleted and this 3 will get added into the heap so that it returns the maximum possible sum. Our output is going to be 3 and 3. In the second example, minus 1 will be the only element, minus 2 comes. When minus 2 comes, in order to maintain the heap property, it will be getting added, and the length of the main heap is not now equal to 3. Hence, it can be allowed maintaining the heap property. When 3 comes, it can also be allowed since the allowed length is 3. But when 4 comes, it should decide whether to allow the 4 or minus 2 or to retain the minus 2 itself. Minus 2 should now be removed from the main heap because 4 is the largest. So 4 is added to the heap and it is again reheapified to maintain the property. Since we have no more elements in the array, this sequence will be written in the ascending order. Because the relative order should be maintained. That is the constraint implied on a subsequence. When we ran the code, it successfully got compiled, and this is our code. Using the scanner class, the number of elements n is taken as input, array is got as an input, array elements are stored, and k is got as the input. We are maintaining a priority queue here, and this particular condition to maintain the heap property, and we are not going to maintain only the element but along with the index it is going to be stored for maintaining the relative order of the subsequence. Heap will not maintain the order of the subsequence, so the index should also be maintained. Hence, an element along with its index is stored as the element in the priority queue min heap. And inside the min heap, the array element and the index is stored. When min heap size exceeds the subsequent size k, we then do min heap dot poll, which is nothing but removing the smallest element, that is the root element, and the current element is already added. Once that min heap is created, we now transform that min heap into a list of integer arrays which contains the array element along with the index, and that is going to be several pairs of length k. Why do we need to do this? Because we need to maintain the relative order of the subsequence. So in order to sort this particular thing, we just make a list of integer arrays and then do a sorting based on the index. So this is going to specify the index. Now a result array is created in which only the selected elements is considered, disregarding the index, because our concern is only to maintain or return the elements alone, not the index. So that particular thing is only getting stored in the result. Again, if the result can be sorted, it will be easier to process. So we are sorting the result array as well, and we are printing it to the console. When it comes to the complexity analysis, for maintaining the heap, it is generally n log k, and we are doing a sort because in order to maintain the relative order of the subsequence, so sorting the elements by index is needed. So the overall time complexity is going to be n log k. When it comes to the space complexity, we are maintaining a min heap of length k, and the final the intermediate list selected and the final list result all occupying space k. So it can be generally set as O of k. Thank you for listening.